Limits and asymptotes. Line y equals 5 is a horizontal asymptote of which of the following functions? Okay, so the idea with an asymptote is it's a line or curve or something which you get closer and closer to but never quite reach. I assume there's a formula for finding horizontal asymptotes. I never learned it though. So we're going to assume that this is the horizontal asymptote, 1, 2, 3, 4, 5. And we have a function that looks kind of sort of like, maybe like this, and it goes off forever. Maybe like this, it goes off forever. And it gets closer and closer to y equals 5 as x approaches infinity. It could probably be negative infinity as well. So we want to find something that as it goes to infinity, it approaches 5. So what I'm going to do is I'm just going to go through these and see which one of them works. You have about 2 minutes. It shouldn't really take that long to go through each of them. So for this one, so we're doing limit as x approaches infinity. Get rid of that random stray red dot. Okay, so start with this one because it looks easy. X goes to infinity, y goes to infinity, no. X goes to infinity, you get 1 over infinity, this will go to 0, so nope. So, because this will be basically the same as 1 over infinity, which is basically 0. This one might do it. So what you do is you factor out the x. You have 1 over x minus 1. So what we did was just rewrote it so that we could cancel out the x. This goes to 0, and then this would be 5 over negative 1, which does not equal 5. So no, that's a horizontal asymptote towards negative 5, not 5. This one, so this would be sine of infinity, but since sine oscillates, this will just oscillate between 1 and negative 1. So it'll keep going up and down like this. Doesn't ever even get to 5. Okay, so this one, which I was kind of avoiding because it looked complicated, might actually be the one we have to go with. If I was really confident, I'd just say that was the answer because the others aren't the answer. But I should probably check just to make sure. So we have x squared, 20 minus 1 over x. Factor down x squared. And then we have x squared. I'm going to do 4 minus plus 1 over x squared. Change colors just so we can show that I'm canceling. This 1 over infinity, because we're doing limit as x approaches infinity, goes to 0. 1 over x squared goes to 0. Even faster. This then becomes approximately 20 over 4, which is kind of sort of like 5. So this will be the answer. This one, as x approaches infinity, will approach 5. Approach but never quite reach. I think it would probably be approach from the bottom, because if you put 0 in here, you get 0 over 1, which is 0, so it starts at 0. So it probably starts at the bottom. It might cross the asymptote, but then, so even if it crosses, it can still be an asymptote. You can still have something that looks like this, but then approaches the y equals 5. So just because it crosses doesn't mean it's not an asymptote. Asymptotes really you only care about asymptotes at infinity.